So there is a function that looks like you would need to find the, use the antiderivative power rule on it. However, it behaves in an interesting way. So let's rewrite this as the antiderivative of x to the negative 1 dx. And let's try to do that power rule that is an antiderivative. All right, so then this would equal x to the negative 1 plus 1 over negative 1 plus 1 plus c, which is x to the 0 over 0 plus c. So this is the problem because you would end up dividing by 0. So this is impossible. This entire process is impossible. All right, so we got to scrap that and we got to ask ourselves, is there another way to do this? All right, so what usually goes in this spot is what you guys would consider your derivative term, because we start off with f of x, right? And we take the derivative to get to f prime of x. Hold on. Deriv. Right? So what you land at is your f prime of x, and you're usually using your derivative in order to get back to what your original function is. So your antideriv. Right? So let's assume that 1 over x is your derivative. It is what you get right here. Right? So then if that's true, if we have f prime of x equaling 1 over x, then we have to ask ourselves, what would be the original function? What function allows us to land at 1 over x as its derivative? And you should answer from what you learned earlier in the semester that that's natural log. Okay, so let's consider that. The derivative of the natural log of x, 1 over whatever's after it, 1 over x times 1, right? So that checks out. So that means that if we're going this opposite way and we start off with 1 over x in our antiderivative, this should be the natural log of x plus c. Right? It's a little bit more complicated than that. You have to put absolute values around the x. Okay, you need to commit this one to memory. Right? This is kind of counterintuitive, so I'll write that down. The integral of 1 over x dx equals the natural log of the absolute value of x plus c. So this means I can do any variation. So the integral of 5 over x dx, let's rewrite this as 5 times the integral of 1 over x dx. So this equals 5 times the natural log of the absolute value of x plus c. Okay? I could put a fraction in there, the integral of 8 over 27, x in the denominator, dx. You could rewrite that as 8 over 27, the integral of 1 over x dx. Okay, again, you have to commit this one to memory. So this equals 8 over 27, the natural log of the absolute value of x plus c.